Okay, so where we were last time, which it's been a couple of weeks, so probably memories are a bit fuzzier than usual. But I was making the argument that, like, one of the things that we want to preserve from the computationally omniscient setting is this kind of equation of decomposing updateless decision theory across branches of possible observations. And I presented this very sketchy and speculative modification of logical induction using Jeffrey Bulker preference structures, which would give us a property with respect to the expectations that's kind of analogous to the propositional coherence that we have with respect to propositions in order to make this kind of decomposition make more sense. However, what I did not do was explain a notion of observation that we're going to decompose along, right? And so um, the next problem that we're going to tackle is this question of what is an observation for a computationally uncertain agent? Uh, so like logical induction doesn't come up with an obvious notion of observation to represent the information it gets by thinking. It's not a theory that we get to just say, oh, our computational uncertainty is refined by observing the output of computations. That's not quite how it works. And radical probabilism, which is the broader philosophy that logical induction kind of fits in with well, explicitly denies the idea that updates are always associated with some proposition that we observe and that justifies the update, because it allows rational agents to just kind of change their mind. Yet, we need a notion of observation to construct these branches in this decomposition. And furthermore, and maybe even more importantly, we need a notion of observation in order to construct a notion of policy, which is critical for updateless decision theory. And so you guys already know what solution I'm going to propose here, which is Sam's Bayesian logical induction. So the basic idea is that in absence of any other proposition that we can index our updates on, we can simply say, well, the observation is just the whole belief state. And so philosophically, this is kind of saying, like, if I can't account for my change in beliefs in terms of some other specific proposition that I can observe, at least the change in belief itself is this thing that I observe, right? And so this is kind of a map of what we're doing. So we have the whole space of logical inductors, and then we have the propositionally coherent logical inductors, of which this is wrong. Yeah, the logical induction algorithm. I put the logical induction algorithm in here because it tracks the worlds, and it's kind of maintaining. I wouldn't say I change my beliefs because I expect to change my beliefs. I would say I observe that I have changed my beliefs. Like introspected and I noticed that I now believe this. So I changed my beliefs somehow for whatever reason, and then I observe it. But yeah, so we want something propositionally coherent, and then furthermore, we want Bayesian logical induction, which gives some extra constraints on top of propositionally coherent. And so this is kind of making things more and more like classical Bayesianism, more and more like what we expect. And then I drew this black circle of like some other constraints that we don't necessarily know exactly what are yet, although I'll have some things to say on them a little later in the talk. That's what we need. So we're trying to find something that meets the BLI conditions, meets the propositional coherence conditions, and also meets some further conditions that will allow us to prove nice things about updateless decision theory.
So it's not clear to me like why this is the appropriate approach to take. If radical probabilism denies that updates are necessarily associated to observations, then the most direct way to modify the theory seems to be to define policies and also the decomposition in a way that also allows like other other kinds of branches or other kinds of action dependence rather than observations, or is it like or is it like the other kind of sense would be like observation is just a name and we are trying to fit the actual concept, which isn't like what observation is thought of like in the standard.
Yeah, I think you could think of it like that. I'm certainly open to if you have other ideas. But I guess I could say like in my mind, things are fairly like pointing in this direction because so suppose you want to create this alternate notion of policy that isn't like a policy on observations, it's some kind of more general policy object in keeping with radical probabilism. Then because there's no observation, it seems fairly natural to say, okay, so a policy should just be a function of the whole market state. So we have some function of the whole market state to an action, and that's like the space of policies we're considering. And then to say like we're treating observations as the whole market state is just kind of the same idea as that, right?
I don't understand in what sense does the originally valid observations, like before we had this concern, how are they captured by defining all observations as whole market states? I thought that there would be like something external to the the actual empirical stuff.
So the actual empirical stuff gets put in the deductive process, and the deductive process forces those market prices to be one, and the prices of the negation to be zero. And so it does get put in the market state in that sense.
I see. That makes sense.
So like if we considering counterfactual mugging, at some point there will be like a coin will land one way or another, like, and this will be, and the deductive process will inject this belief in the market.
Yeah. Yeah. So in that sense, I feel like probably thinking of policies as functions from market states to actions is right. You could further ask, okay, we can do that, but we could do that without necessarily enforcing these Bayesian logical induction conditions that I'm going to cover, right? And so then the question is, do these conditions for Bayesian logical induction actually play a role in whatever final theorem we want to make, like the tiling theorem that we're trying to develop? And the honest answer there is, well, I don't know the answer to that, right? Like, we don't have the theorem yet. So in this like second half of the talk, that's covering this computational uncertainty stuff, I'm basically sketching out my speculations and intuitions of what properties are going to be important for such a theorem. And I could be wrong. So that's just to say, like, I definitely welcome alternate views on this stuff.
Sorry, I don't know what LIA is. Maybe I forgot.
Oh, that's the logical induction algorithm. But I
Okay.
I actually put it in the wrong place. I think it should be over here because it's not propositionally consistent. An easy variation of it could be propositionally consistent, but
so it should be like outside, but with an intersection with BLI. Is that correct?
Why?
Because it might be propositionally consistent in some special case. Oh, that's not.
I was thinking of this as the logical induction algorithm that's actually in the paper, rather than the logical induction algorithm plus some easy modifications of it.
I guess then it should be a point, not an area.
Oh, that's it has a lot of parameters.
Okay.
But yeah, that's a fair point. Okay. So yeah, I'm gonna move on now. So maybe I already kind of said some of this stuff, but so philosophically, what are you observing? If you think for some time and change your mind, you could be observing some argument or some computation, but radical probabilism wants to leave room for us to kind of freely change our minds. This might seem irrational, but I think it's a useful exercise to keep our notion of rationality as broad as possible. That is to say, we don't want to rule out somebody as irrational only for being arbitrary, right? Like, values are arbitrary, even on like pretty standard views of rationality. And so if you just arbitrarily change your mind, that in itself isn't necessarily irrational. And so the philosophy I'm clinging to here, there could be other alternatives, but I'm kind of clinging to this Dutch book picture where you're only irrational if you're like predictably Dutch bookable. And simply changing your mind on an issue does not make you that. Therefore, observing beliefs themselves leaves agents with the freedom to come up with these beliefs in whatever way they like, and doesn't treat any particular type of evidence, such as empirical observation, as fundamentally special. All of the beliefs are equally thought of as evidence. While still giving us a notion of observation, which includes enough that it seems like we can reconstruct something like updateless decision theory. So, yeah.
Sorry, what do you mean by beliefs are observations? Oh, sorry. Yeah, you said that beliefs are observations, right?
Yeah.
What do you mean by that? Like, what is it in the same sense? Beliefs are observations as in Bayesian logical inductor, or in some more broad philosophical sense?
Really, the key thing that I want to mean by this is when we are developing our concept of policy, like, what is a policy point? A policy point associates a market state, so like a belief state, with an action. And that's the key claim I'm making. Yeah, so Mateusz in the comments said they're the stuff that makes you change your beliefs. You notice that your beliefs imply something. So yeah, in Bayesian logical induction, the way in which we're going to treat beliefs as observations is we're actually going to, in order to go from belief state 1 to belief state 2, we're going to condition on belief state 2. So that's the sense in which beliefs are observations in Bayesian logical induction, is that that's the thing that we do a Bayesian update on. We do Bayesian conditioning on the new belief state in order to arrive at it. So it's like you're just like, kind of introspecting, and
But where do you get it?
Yeah, well, I'll show that in the construction.
Oh, okay.
So yeah, Sam's approach is to take a propositionally coherent logical inductor, which I'm going to call bold Q, and transform it into a Bayesian logical inductor, bold P, which meets some additional rationality constraints. The transformation modifies only the prices of large sentences, so that the price editing that we're doing in order to make a Bayesian logical inductor doesn't threaten the logical induction criterion, because if you only change large sentences, then this doesn't threaten any logical induction criterion, since it only depends on small sentences. So I'll use this kind of script queue to denote some notation within the logical language L of the inductor for a list of prices for small sentences on day n. So a list of prices that this bold Q in could have. So then Sam's constraints that he's enforcing on a Bayesian logical inductor are that Pn of phi approximately equals Qn of phi for phi which are small on day n. This approximation is due to some discretization that he chooses, that like the approximation has to be quite good in order to not threaten the logical induction criterion, but there's some small epsilon that we allow to be approximated. And the reason for this discretization is because down here we're going to sum over them. So there have to be a finite number of possibilities for the sum to be well defined. So this is saying that, you know, on small sentences, the prices basically just agree. Number two, if we condition on bold Q of M equals script Q of M for some M greater than our N, then the probability of phi conditioned on that is just whatever script Q says. So we're just pulling out the price from that price list. So this is saying that when we condition on this update of like, here's what the future self thinks, then we just believe it. And then 3 is similar, saying like, when we condition on multiple of these, we trust the higher one. So that we can condition on several of these in a row and we'll always believe the largest one. And then number 4 is the beliefs about the possible QN. So we have some distribution over the possible future beliefs are required to balance this equation that's like conservation of expected evidence or no expected net update. Yeah, Roman?
Shouldn't there be Qn in the last equation, like Qn of phi? The last equation on the page.
The last? Oh, yep. I think, yep, there should be a QN. I agree.
And also the question, in what sense do we mean condition on? Do we mean like phi and like phi conjunction Qm equals to Qn divided by P of Qm equals to Qn?
Yep.
This one.
Yep.
Okay.
It's supposed to be the normal Bayesian conditioning. And so that's why Qn has to be propositionally coherent in the first place in order for these sorts of things to work like we expect them to work.
So can I ask something about like Qn is what could have been, like, so it considers that it might believe in the future something like a lot like so if the discretization is like 10, for example, then like it considers, it believes some proposition, some sentence with probability of 0 or probability 0.1, 0.2, and like it considers all possible combinations of this discretization on all of the beliefs, on all of the sentences. So it's like hypercube, a lattice hypercube.
Yeah.
It gets finer each day.
Right. It gets finer each day at a pretty rapid pace. I'm not sure exactly how fast it needs to go, but it needs to go fairly fast to not mess up the logical induction criterion.
And also hypercube grows in dimensionality because we have new and new sentences.
Yep, it grows rapidly in dimensionality as well. So yeah, there's some super exponential stuff happening here for sure. So the answer to your question earlier of where does it get these beliefs is that, yeah, we're taking this logical inductor, the propositionally coherent logical inductor, and so it's like a picture of a Bayesian who completely trusts some logical inductor. whenever they get the new observation of, this logical inductor thinks such and such, they just jump to those beliefs. That's what a Bayesian logical inductor is doing.
So we have a regular logical inductor somewhere.
Yeah. So you can think of the regular logical inductor as kind of like the subconscious mind of this thing. And it's just like offering up these new beliefs to the conscious mind, and the conscious mind is like, okay, I trust it.
So in some sense, we just have a reformulation of the logical inductor. Just like we have logical inductor, and then we view it in different way.
Yeah. Yeah. So it's kind of a hacky construction in that sense. It's not some beautiful like, if we do things in this way, we naturally get these properties. Instead, it's just like the minimal modification of the logical inductor to meet these conditions.
Is there a proof that such thing exists?
So there's definitely not like a nicely written up proof. But let's see, okay, I think I actually didn't make a slide on this, but in there's some more details in the notes that are in that Less Wrong draft post that we're using for a kind of a note dump. So the proof that Sam suggested, Sam suggested two proofs that this thing exists. The main, like, we can do all these edits to the large beliefs however we want. So 1 through 3 are kind of easy to say, well, such an object exists. We just stipulate it. But then number 4, we need to balance this equation. So that's the trickier part. So Sam's first proof that we can balance this equation was to suggest that we can just take the point distribution where these probabilities just have a point mass on the future prices are going to be exactly equal to the current prices. Or maybe like the discretization will make us move them a little bit, but just like whichever discretization point is closest. And then, actually, no, that wouldn't work. So we have to have the property that the discretization lets us pick exactly the same point. And then you have probability 0 on all of the other possibilities. And then this equation is, of course, satisfied. So, yes, such an object exists. But, of course, that's a very, very unsatisfying example of such an object, because putting all of the probability mass on tomorrow's prices being exactly the same as today's prices is absurd.
No, that's not what it's doing. It's putting the belief that the tomorrow's prices will be the same way they will be as you believe them to be today. This is weird. Like, you already know the future in this construction.
You know the future, and also you're wrong about it, because tomorrow's prices aren't going to be the same as today.
Wait. Then the equation is not going to be balanced, isn't it?
It's balanced because, so you have like, here's n minus 1. You're trying to get the sum over all this stuff to equal the prices at n minus 1. And the only non-zero element of this sum is just exactly the q that equals n minus 1, the p at n minus 1. So it balances the equation.
Oh. So Qn is equals to Q, like Qn both equals to Qn script, but Qn script is the same as Qn minus 1.
Exactly. And that's the only one for which we place positive probability. And we put this probability to 0 for all of the Qn that predict something different than that.
That does seem unsatisfying. Deeply.
So we can prove that these exist, but in proving that these exist, we're really showing that like we are obviously missing some rationality constraints, right? Like that's not a satisfying way to satisfy all these equations. So it seems we really like the kind of game that Sam is playing is taking logical induction rationality as a given, but then trying to add some constraints about how small beliefs relate to large beliefs so that we have some kind of coherence there. And he gives these 4 rationality constraints, but it seems these 4 rationality constraints are really not enough because we can satisfy them in this very dumb way. And so I think that motivates the claim that we really want some additional rationality constraints on top of these 4 constraints, although we might not know exactly what they are. Yeah?
At which speed does the amount, like these beliefs grow, like the small beliefs grow? So on the day n, you don't have the belief about the Qn, like logical inductor, considering Sam's construction. Would it have some beliefs about this construction on day n, on about the nth day, on n minus 1's day?
So the speed at which the small beliefs grow should be faster than any polynomial, and like also slow enough that these large sentences about like the day's prices equal this script queue remain outside of the small sentences.
So they will be forever out of reach.
Yeah. And so, well, not for, each individual one eventually comes in, but yeah.
Not on the day n.
Right. Exactly. And so the obvious choice for the definition of small sentences is whichever sentences the traders have touched on that day. So if a trading strategy includes claims about a sentence, then we call it small.
So here's the thing, like there is a small belief, there is a small sentence, which is something like, I believe that all of the beliefs on the day n will be, all the probabilities on the day n will be larger than 0.5. And at some point in the day n, this will be a small sentence for this day n, right?
I believe that all of the beliefs on day n will be
like,
sorry.
It's yes, something like, well, for any belief in the on the day n, the probability of that sentence will be larger than 0.5. So it, in some sense, self-referential.
Okay.
So it's a reference on the day n. So this belief, I think, will be a small belief for someday n.
Yeah.
Because
Okay.
it's like constant length. It's efficiently computable.
Yeah.
Can we extract some rationality from those beliefs, those compact beliefs, and like impose them on this equation?
Okay, yeah. I think this is also in line with my intuition. That
Okay.
somehow we could say this is giving us the marginalization, that the distribution over these Q should be such that it, when we kind of squish it, then it, the marginal we get for each of the phi lines up with the small beliefs. But we also want some sort of distribution thing where, like, we don't just want the probability of phi to equal 0.5 or whatever. We want our beliefs about the distribution of possible beliefs about phi tomorrow, which is a small object. Like, we can have like small propositions, like you're indicating, like speculating about what the price of phi will be tomorrow. And so then this distribution that we have over the Q in the large sentences should also cohere with that. And then that would rule out this strange point estimate style belief. Yeah. So yeah, I'd be interested in a worked out theory of that. Should I go on?
Yeah.
So P is now a logical inductor since it agrees to within vanishing epsilon with Q, which was a logical inductor. Furthermore, we can see that P's updates from Pn to Pn plus 1 are a Bayesian update, since the probability of phi at n plus 1 equals the probability of phi at n conditioned on something. Notice that Sam's constraints 1 and 4 imply a version of conservation of expected evidence, also known as no net expected update. Oh yeah, okay, this is the discussion, yeah. So we can prove that number 4 is feasible by choosing this pathological set 1 value to 1 and everything else to 0. So here I have some speculation on deriving Bayesian logical induction in a more natural way. I don't know if this speculation is good, but so just as propositional coherence precisely enforces rationality constraints, which any logical inductor will learn in the limit, we would like to derive Bayesian logical induction by precisely enforcing some rationality constraints which logical induction provably learns. A natural idea is to universally enforce this kind of future self-trust or conditional trust rule that when we condition on some future price for phi, then our price of phi conditional on that is exactly that future price. However, this condition is simply inconsistent. So because of some self-referential sentences like the sentence L, which says that the probability of L at time m is less than 1/2, if you condition on the value of exactly 1/2, then the correct belief from like Yeah, I should have been a little more detailed. It's not outright inconsistent. It's inconsistent with recognizing the implication from that to like actually PL is 0, right? Like if like it's a deductive fact which can be in the deductive process that if the probability of L at time m is 1/2, then L is false. And so if that deductive fact is in the deductive process, then conditioning on the probability being 1/2 ought to give us the probability 0 rather than spitting back out the same probability 1/2. And so this is too strong. Did that make sense?
A bit of sense, like not fully. Like it's like I understand that the actual probability of the statement, like if we condition on this fact, we can like this is the probability like of the like probability of what? Probability of L conditioning on the fact that probability that the belief of M is equals to 0.5.
Yeah. So yeah, put L for phi here, and then put 1/2 for P here.
Yeah. Then the probability of that is equals to 0 because
Right.
it's going to be
should
inconsistent.
Yeah, it should be 0 instead of exactly the same. Yeah.
It should be in the sense that this would we who understand this language and who can think forward, like consider implications, this would be the right thing to put here.
Yeah. And so if the deductive process also the claim I'm making is that if the deductive process also recognizes those implications, then it will put 0 here. And so it will be inconsistent with this rule.
So enforcing it will contradict some, yeah.
Yeah. So it will no longer be a logical inductor because it will be forced into a consistent position. Yeah. At some day, yeah. So I've written out the weaker property which logical induction actually learns. So this has a bunch of notation which probably you don't immediately know what means. There's a good discussion of this in the logical induction paper itself, explaining the connection between this statement and this statement and this kind of inconsistency problem and why this is the more desirable rationality criterion. But I've also, in that less wrong draft that we're using as a wiki, I've given a somewhat expanded discussion of this, if you want to look at that. So just going between these two statements in a larger number of steps so that you can more slowly see the connection. But so yeah, this statement is kind of similar to this, but it's weak enough to actually be true of logical induction. But still, logical induction doesn't precisely enforce this constraint. Rather, it learns it in the limit. So the question is, can we enforce this constraint exactly? Does something go wrong if we try? I'm not sure. And if we do, then does that get us some version of Bayesian logical induction? Or not? And is it, like, in some sense more satisfying than the construction that Sam gave? So yeah, that's my idea there. Yep.
Can I ask about notations, or it's like
Yeah, you can ask if you want.
or it all written somewhere, like in the notes and
Yeah, but I think I
actually-
can answer your
okay.
questions if you just want to ask.
Okay, the expected value on the day n, is it like in the same sense it defined on the like the expected value of logically uncertain variable on the day n with the precision n?
Yeah, so it's
Like e expected n on the day n. Or they shorten this notation to like just expected on the day n.
right. Yeah,
Probably.
yep. It's exactly that.
So the in some sense, like it uses not really large beliefs, but like are they not large beliefs? Like there might not be such a belief to construct this to construct this expected value, or is it dealt with? Like
Yeah,
they
I think it is small beliefs in the sense of like it eventually small because these expectation operators are like efficiently enumerable. And so actually I'm not sure.
well, you're talking about some. So inside you have this like belief state PM, right?
Yeah.
The M is arbitrary, right? It's even greater than M. You
Right.
definitely can't enumerate all of the
That's right.
days M futures than N on the day
Yeah.
N.
Yeah. Right. So when I talk about enforcing this exactly, I'm definitely talking about enforcing it in some large beliefs as well as some small beliefs. So yeah, this M. So right, what they do in the paper is they're not just setting an arbitrary M like this, but rather they're using
F
the
deferral function.
exactly the deferral functions so that you kind of take care of this problem of yeah, because you can refer to the deferral function values efficiently.
Well, like not only the deferral function values, but all of the previous values and all of the beliefs about the values on the ends, like on the with the precision of n, like all of this,
Mhm.
and not only like like this hard expression, like this is really long, logically uncertain variable. And you need to have a beliefs about that. You need to have n beliefs about this. So like yeah, it's a lot. Like yeah, but if it's a deferral function, it will learn eventually all of these beliefs in the timely manner.
Yeah,
Okay.
yeah. So then I'm asking, well, instead of learning these in a timely manner, can we just insist on this? And
Why
if we,
insist on inequality?
so, so if we change this to an inequality and we change this to an inequality, then it seems like it still ought to be true in the same way, right? Like, like this is intuitively like, well, we trust these future beliefs. So if we knew exactly what they were, then we would just believe them. Similarly, if we trust these future beliefs, then if we know they're greater than something, then we would put our belief to be greater than that thing, right?
Yes, and
So
but
this
but
is
self
just this is just kind of one of the transformations along the way to get to this thing that's actually feasible.
What I'm asking is like we insisting on inequality, but like there is arbitrarity in this. Like what should actually we put here, or like we don't care, like just insist on it, and like this doesn't matter. Is this question even matter? Maybe not.
I mean, I think that you can consider different versions of this thing. Like, I'm just speculating here, right? I'm just like, I pulled something out of the logical induction paper, and I'm like, I modified a little bit by putting these im instead of the f of these functions, deferral functions. And I'm like, maybe we can enforce this exactly, and maybe that gives us something like Bayesian logical induction. I haven't thought about it enough. And so these are the right kinds of thoughts to be thinking in terms of like altered versions. Like maybe we don't want the inequality version, maybe we want an actual equality version. I don't know. Yeah. Like,
okay, this is a tangent. Okay, sorry.
But so yeah, there's things to try to get some sort of more natural version of Bayesian logical induction. Shall I move on?
So yeah, I don't really think this is a tangent. Doesn't this relate to the problem of self-referential sentences? Like this inequality version you proposed. If I'm not mistaken, it seems to avoid that
I think that is not true.
inconsistency.
So suppose that this was an inequality, but otherwise the same.
So you mean you
Yeah.
just put phi on the opposite side of the inequality, and then the same problem remains. Are you trying to
Yeah.
say that?
Yeah, I think so. Yeah, this is like one of the things that I don't have it right in my head right now, but this is one of the things I was thinking through when I was like making this slide. Because like this sentence is like, this is strictly less. We can also consider the version of this sentence that's like less than or equal to instead. But so if we knew that the probability of L is greater than 1/2 or greater than or equal to 1/2, then still the probability of this should be 0. Right? So the inequality really doesn't save us. It's just like one of the steps along the way to saving us.
Can I like?
But the product.
Sorry.
Okay. Sorry.
No, you were first.
Okay. The product of the indicator function for phi and the indicator with subscript delta. If phi were if phi is actually like PM phi is less than P, wouldn't that mean that? Oh, so you mean like this product, the expectation of this product should be 0 because the range at which there are non-zero should not overlap. But this inequality would be stipulating that it's above some positive number. So
that sounded right, but I'm not 100% confident that I followed everything you said. So
yeah, but I'm restating essentially the same point. So I don't think it's
okay. But you're taking this and you're saying, okay, why is it consistent down here, right? So
yeah.
I'm not sure what Norman asked, so yeah, I wanted to ask, like, is this working with self-referential sentence you have here? Like, is it saving us? Like, this works with self-referential sentence.
Yeah, so if we have L, I think this is the same thing Norman was trying to think through as well.
Okay.
Yes.
So if we consider the phi equals L down here, then like the claim is that it should be about 1/2, right? Like our estimate of the probability of L at any time before M and even at M, but not after M, should be like around 1/2, but with some uncertainty because like it's 50-50 whether it's going to be above or below 1/2, right? And so if we imagine that we're looking at something like that down here, then the indicator for phi being true or false times the indicator for the probability of phi at the time M, that is the time for which it's defined, is above 1/2.
This should be 1/2. This indicator. Oh, it should be. Oh,
In the cases where like we're imagining like yeah, it's above 1/2. So this like this is true when this is false, right?
the way
L is
delta.
like this is an indicator for it being below 1/2, and this is an indicator for it being above 1/2.
So here's the thing. There is like so when we think about how close the probability of the sentence to 1/2, it should be so close so no trader in the pool on the day M could differentiate between this number and like 1/2.
Yeah, right.
The way the indicator function is constructed, like it depends on the
Right.
delta.
Yes,
How
right.
fast
Thank you, yeah.
delta is compared to the traders.
That's right. And that's critical here. Yeah.
If it's faster than the precision with which market can discern, then it's one thing. It's if it's greater, then it's another thing. I believe like if it's really if it's much bigger than what the market can discern, it's just 0, because the probability. So x here is probability of M, so it's really close to 1/2. The probability starts growing with x growing, so it's like about 1/2 with the delta of the market, and it just a little bit bigger on or a little bit less than this threshold value, which is 1/2.
And so this is like 1.
This is 0. No, this is 0, because like it's just starting to grow when x is greater than 1/2.
Oh, right. We have the definition right here.
It just started growing, so if the precision of the market is much bigger than the delta, then it is 0.
Okay. But then similarly, this one over here will be 0.
Yeah, this would be the same number.
Because it's the same number. And so the inequality holds. Okay, so it works in that case.
Yeah, seems like that.
Okay.
Well,
yes.
if the expected value, like if the expected value learns enough about this deltas stuff.
That's right. Yeah. So, okay. So I'm going to move on to something a little different. So if there are any more questions on this or comments, then I guess I should make a little time for them.
I still don't understand everything about that's being said today, basically, because I I I don't see why it makes sense to condition on a sentence like your your uh, your belief on day M being of phi being true being P. Well, what does this actually mean? Like do we, is this supposed to capture how the agent actually reasons, or is it like, you know, like physics model, like simulating simulating the belief evolution process in such a way that it happens to be rational?
Yeah.
I'm just not getting the sense that this is how we reason, and
Yeah.
I'm also not getting this why we're doing this.
I think Sam and I both are of the opinion that this is more like a, as you put it, like a physics model, like the radical probabilist philosophy is kind of closer to being like practically the practical truth. But this is like a way of saying, like, well, if we want to be dogmatic Bayesians, meaning that we think that when we get evidence that's in the form of a proposition, which we come to know with probability 1, then this is a way of saying, like, you're not fundamentally losing out. The radical probabilist and the dogmatic probabilist are kind of equivalent because of this construction, that you can view the radical probabilist perspective as a dogmatic Bayesian by saying you're conditioning on what you come to believe. And so that's like the philosophical point that's being made, that the radical probabilist isn't fundamentally doing anything that the dogmatic Bayesian cannot do. And then the reason why we're doing this here is because updateless decision theory needs this notion of observation in order to define policies. And so in order to try to create an updateless decision theory that's computationally uncertain, and try to get it to respect some tiling theorem that is like what we would hope for, then I'm trying to translate the radical probabilist type perspective that's introduced by logical induction into the dogmatic Bayesian perspective, where we just have regular Bayesian updates, so that I can apply updateless decision theory to it.
Yeah, that's I think a really clear explanation. But is this really right? Like, So I think so. Maybe if you want to move on, you can move on. I can discuss this like privately, but I also feel like this is kind of relevant for others. Are you guys all interested in hearing me ranting more about this, or should we cover some more? Okay, that's not a good way to ask people. So I think is
What,
I
Mateusz, broadly speaking? I don't get what you mean by that,
I mean,
Mateusz.
I
he's
meant
saying like
that I am broadly
Thomas,
interested
broadly speaking.
in normal
He's answering in the affirmative.
Okay, yeah, because I'm like, well, starting on the next thing would probably fit well for like next time. I know I'm moving through these things slowly, but I feel like the next self-contained piece is fairly long, so I'd have to like review it anyway next time. So I'm fine with like the rest of this being more just like discussion.
Okay, thanks. So I think here is like a question of like the research philosophy. So I get the feeling, although I admit that I really understand very little of what is being said here,
Mm.
but it's like if we are doing like some minimal modification to both like UDT and the decision theoretic framework and the logical inductor, it seems that we're working with a lot of constraints that these theories impose on us. But but it's not like we necessarily accept these constraints philosophically. It's just like it's like we're fitting our ideas to the tools.
Yep.
Yeah.
Yep. I've been
And
accused of this in the past.
but
So I guess my intuitive answer to this is like, I've tried a lot of other things, and this seemed like the way forward. So in principle, I'm certainly open to a broader set of possible ideas of like more like reformulating our basic ideas. But I haven't been convinced of any such approach yet. Like, I feel that in order to, I guess one way of putting it is, I think this really, the difficulties that we face here in trying to get these two formalisms to go with each other of updateless decision theory and logical induction seems to me like really the fundamental core difficulties, as opposed to some artifact of philosophical commitments that have been made. So yeah, maybe I can't like readily provide like evidence for this claim, but it seems to me like actually pretty difficult to try to instead throw away some of these philosophical commitments, maybe dramatically reformulate updateless decision theory or dramatically reformulate logical induction, or both, in the service of or maybe like toss both aside and try to come up with something new that gets kind of the strength of both. Like, for example, some work with Caspar Osterheld that I did, the Bria paper, so bounded rational inductive agents, Bria. So this formalism was an attempt by Casper Osterheld and me to say, okay, well, like logical induction was pretty great, but logical induction didn't immediately give us the like decision theoretic insights that we wanted. Like it was kind of at MIRI, it was kind of expected that like, we've come up with logical induction. This was this big piece that we needed to fill in of our theory of rationality. And now we should be able to get a bunch of consequences for decision theory type stuff. And then that just kind of failed to manifest over the course of the next couple of years. And so Bria was like Casper Osterheld and us and me thinking kind of like, okay, so if you think of yeah, our thought process was complicated. Maybe I shouldn't try to recapitulate the whole thing, but basically trying to do the same thing for decision theory that logical induction did for epistemics. And so trying to create this decision theory from scratch that just like satisfies this, like, how do we deal with computational uncertainty kind of a question, but purely in the decision theoretic arena, rather than trying to build upon the epistemics that we've come up with for such cases. And that was successful in a way, but the picture of rationality given by that still completely throws out updatelessness. Like within this formalism, trying to think about this question of like, okay, what's the correct updateless approach is it just feels wrong. It's just like there is no absolute like correct updateless. You can specify asymptotically like more and more updateless, but this just makes it seem obviously arbitrary, right? So you can like devote like half your time to thinking about what the right probabilities to assign to mathematical statements are, and then the rest to like using that as the prior, like figuring out your policy or different ratios like this. But then that makes it like kind of obvious there's no correct ratio. And so in this formalism, it's really just kind of pushing you to give up on updatelessness in a way. And so I really started to think like, like this formalism of just doing decision theory without epistemics is kind of the opposite direction of what we want to go for AI safety, in the sense that Bria is a theory of decision theory that isn't even realist about like the evaluations of alternative actions. The only guarantee that you get out of it is that you have a good estimate of the quality of the action that you actually take. But even the alternate estimates of the other actions that you could take are not guaranteed to be good in any sense. And so it's like as little epistemics as you could possibly imagine. The only epistemics that you have is this one estimate of the quality of the decision that you will make. And you don't have any beliefs on mathematical propositions. You don't have any beliefs on anything else. And for AI safety's sake, we really want a decision theory that gives you as much, like it like handles into how the AI is thinking as possible, right? We don't want, sorry, this might be a tangent, but that made me go back to this way of thinking of like, okay, we want like this full epistemic picture. We want to be making decisions for reasons that are scrutable, as opposed to thinking of everything as inscrutable black boxes. And going back to this, like Bria has like a, in a sense, a forced exploration, like not epsilon exploration, but something similar to that. And I'm like going back to like, no, we need like rational decision theory. We need like, if you take an exploration action, it's because of value of information calculations, right? So we, so I guess that's kind of why I'm like back in this context of trying to take logical induction and then like combine it with updateless decision theory. Because I feel like when we made this attempt to get away from that, then it just kind of like obscures everything and makes the problem look even more impossible. So that's my experience.
Okay, thanks for your sharing your thought process. It's very helpful. But I guess I have one like response in particular about like should we make a distinction between a normative like desire for our decision theory to have more epistemics in it and like practical usefulness in terms of like constraining neural networks, or like, because I'm trying to say that do we really expect to have a big handle, like so much handle on the epistemics of these machines? Or do you think like that's beside the point of for doing this work?
Yeah, I guess I think we should want to have a handle on the epistemics. And so my picture is that like developing formal pictures of agency which include better handles into things is moving in the right direction. But I guess I can't give you like the roadmap of like how exactly down the line does that put us in a better position. So you could certainly question whether focusing on a logical induction picture will actually help us develop handles into what neural networks are believing. For me, trying to make a direct line between the two, which is dangerous because, of course, the research will not take a direct line, but like trying to make a direct line between the two, I think of kind of the way that chain of thought gives us somewhat more hope to understand what LLMs are thinking than non-chain of thought thinking, because at least a big part of the actual computation that is running is put in natural language. We don't know that the natural language has the semantics that we naively think it does, but we could consider adding some other precautions to try to make sure that that's the case, such as like paraphrasing. Similarly, if we think of like a logical induction based large language model, then we would somehow create this like market of beliefs. And so we would have like something analogous to chain of thought, but maybe a bit more like factored cognition, where you have these like traders who are like making queries to this market so that their beliefs are a function of the market beliefs of various relevant propositions. And so we would have this trace of like, okay, here's how information was aggregated to answer questions in this way. And that doesn't fundamentally solve the problem of cracking open the black box of the neural network to figure out what it's thinking. But that's actually kind of because logical inductors don't solve the problem of cracking open the black box of the traders to see what they're thinking. So if we had an even more white box kind of picture where the traders themselves were cracked open, then that might allow us to make even more progress. Not that I have an idea of how to do such a thing.
And converse, or rather, maybe not conversely, but like on the opposite side, if such a black box picture like logical induction actually works well and tiles, does that mean that it's not so like pertinent for us to crack open the neural network after all?
I think not. In the sense that, like, remember in the beginning of this talk, I gave that motivation of like the 4 different types of ways to apply tiling theorems, right? And so if we have like a black box tiling to a black box, this gives us the AI to AI tiling picture, but it doesn't give us like the human to AI tiling, which I think is also quite critical for AI safety. And so I think like the question of how the humans can justifiably trust the AI probably involves breaking open black boxes. Because naively, like given what we kind of know about tiling, we think, well, like I can trust another agent more or less to the extent that it has the same values as me. So the same utility function and the same probability distribution as me. But if, like, how could I understand that to be true if it's a black box, right? Like I need to see that it is kind of reasoning about things in the same way that I would, or the same way that I would ideally want myself to in my most, the state of thinking the clearest.
Okay, so I guess if we're thinking about things in a very binary, like crude way, tiling research should at least be able to tell us whether this assumption is correct, like this similarity assumption. Because in the sense that, is it really the case that agents could only tile when I know that your utility function and such are more or less similar to mine.
Yeah, right. This is a big formal question here. And it has to do with this like computational uncertainty thing, because computational uncertainty seems to involve these things changing over time. Like the radical probabilist picture where we can just change our mind. And so can we establish trust in such a scenario is kind of a big part of this research. Roman?
Yeah, I wanted to ask, like, in 101 we discussed like the fact that traders are not, like, they are black boxes to themselves, like in the sense that they don't understand the semantics of the language we are trying to operate.
Yeah.
Yeah. Goodbye. So how can they be white boxes?
Yeah. This is a good question. I don't have the answer to that question.
Okay.
Yeah.
Should we end?
Yeah, maybe we should wrap up. Thanks, everybody.
Thanks. Goodbye.